Now we're going to use the Pythagorean theorem to classify triangles according to their side lengths. And believe it or not, we can easily look at side lengths and tell if they're isosceles, scalene, or equilateral. Now we're going to tell if a triangle is acute, obtuse, or right. All right, now we're going to take a look at TEK G.3, which is determining whether a triangle is acute, obtuse, or right given the three sides. So before you could take a look at the angles, but what if we just give you three measurements and ask you what kind of triangle it is? Here's an example. I've got a 4 centimeter, 7 centimeter, and 9 centimeter triangle. Is it acute, obtuse, or right? Well, the one triangle I know the most about are the right triangles. So if I use Pythagorean theorem, I could check and see if this is a right triangle. So let's go ahead and use that strategy and do the Pythagorean theorem. So I'm going to see if the two legs, which are the two short sides, when I square them and sum them, if it's equal to the hypotenuse, which in this case will be my 9 centimeter side. So substituting in the values, I have a squared plus b squared, so 4 squared plus 7 squared, and I get 16 and 49. My sum is 65. Now I square c. It's 9 squared, which is 81. And 81, if it was a right triangle, these two should match exactly, but they don't here. In fact, it's too big, all right? So if it's too big, what does that mean? Well, if I were to put the side here, it would literally be too big. It would hang out over the 4 centimeter side. So if I'm still going to make a triangle out of it, I know I can't make a right triangle. What can I do? Well, I could tilt out the 4 centimeter side, and I could tilt down the 9 centimeter side. What happens to the angle when I do that? Well, I went from a 90-degree angle to a larger angle, so my triangle's obtuse. So if c squared is too big, then the triangle is obtuse. Similarly, what would happen, let me look at a different set of sides. What if c were 7.5 centimeters? Well, you still use the Pythagorean theorem, and in this case, c squared is too small. So here's my drawing. I have a 4 centimeter, 7 centimeter, and 7.5. So I'm going to tilt the 4 centimeter in, tilt this one out so it matches just right. And what happened to the angle? Now it's less than 90 degrees. So this triangle is acute. So that brings up the general guidelines for determining if a triangle is acute, right, or obtuse using the Pythagorean theorem. So essentially, you can use the Pythagorean theorem and look at c squared. If c squared equals a squared plus b squared, c squared is just right, and it's a right triangle. If c squared is greater, then it is too big, so the hypotenuse is large, the angle has to open it up, and it is obtuse. If c squared is too small, then your triangle has to close up a little bit, making that right angle acute. So I have two examples that are in the table below. They are in that video that you just saw. So we'll go on to example 5C. So I'm going to classify a triangle with sides of 26, 24, and 10. First of all, I recognize this triangle, so I'm going to go ahead and simplify it. Admittedly, you could use the Pythagorean theorem, and it would work out just fine, but it's important to recognize Pythagorean triples. If I divide everything by 2, I get 13, 12, and 5. If I can simplify something to a Pythagorean triple, it is definitely a right triangle. In this next example, I'm looking at triangles with sides of 6, 8, and 9. So you have to identify which one's the hypotenuse and which are the two short legs. Remember that the A and the B, it's not so important. You can switch those. But C has to go on the correct side. I think it's easier to have c squared first, and so I have c squared and then a squared plus b squared that I will compare. Substituting in, I get 9 squared for the hypotenuse side and 6 squared plus 8 squared for the leg side. Squaring, 81, and then the other side is 36 plus 64. And you can see that 81 is less than 100. So that means that c squared is too small. The hypotenuse is too small, so the triangle has to close up just a touch, making it acute. So now for your reflection. Why would a triangle be obtuse when c squared is greater than a squared plus b squared? Think of it in terms of the hypotenuse. Is it too big and you have to open it up, or is it too small and you have to close it, or is it just right and it's a right triangle?